When you look at circuit like this, do you know which resistor drops the most voltage? Is it the smallest one, or the one in the middle, or is there more to it? In today's video, I will show you exactly which resistor drops the most voltage and how to identify it in any series circuit. And hey, if this is your first time of coming across my video, I stand by the name the Smart Voltage Guy. On this particular channel, I teach engineers, electrical physics students, and electrical or electronics engineers how to analyze electrical circuit theory, electrical complex circuit theory, and electrical circuit analysis. This is the perfect place to start. On this channel, I will teach you all you need to know about what circuit theory. And all you need to do is to subscribe to this channel so that whenever I upload a simplified circuit calculation tutorial every week, you will be notified. I mean, subscribe now. Okay, let's dive into it. What is voltage drops? Voltage drop is the amount of voltage used or consumed across a resistor as current flows or passes through it. Is the amount of voltage we use as current I passes through what? That resistor. In a series circuit, current is the same through every resistors, but not every resistors drops the same voltage. And the question is why? Because voltage drops depends on what? Resistance. The voltage that we drop across to R1, it depends on the resistance value of what is to what? R1. The voltage that we drop across to R2 depends on the resistance value of what? R2. Which means the voltage that we drop across to R1 is different from the voltage that we drop across to R2, and is different from the voltage that we drop across to what? R3. Because voltage drop depends on what? Resistance. Okay, let's discuss Ohm's law. We state that V, Ohm's law, according to Ohm's law, V is equals to what? I multiplied by what? R. So therefore, from Ohm's law, the voltage that we drop across a resistor is the current times what? Resistance. The voltage that we drop across any resistor in a circuit, let us say the voltage that we drop across the resistor R1 is what? The current that passes through it and the resistance what? Values. Remember, in a series circuit, the same current passes through all components, but the only thing controlling how much voltage drops across each resistor is what? Resistance. The only thing that will determine the amount of voltage that will drop across resistor R1 is the resistance value of what? Resistor what? R1. And the only thing that will determine the amount of voltage that will drop across resistor R2 is the resistance value of what? Resistor R2, and so on. That means that what? The biggest resistor equals to what? Biggest voltage drop. The biggest value of resistor will equal to what? The biggest voltage drop. I mean, the biggest what? The biggest what? Resistor is equal to what? Biggest what? Biggest voltage drop. While the smallest resistor equals to what? The smallest voltage drop. I mean, seeing this value of resistor is 2 ohms, and here is 4 ohms, and here is 8 ohms. Seeing this 8 ohms is the biggest value of resistor here, it will, the voltage that will drop across the resistor will be what? Be bigger, because what? The biggest resistor, which is the biggest value of resistor, will drop the what? The biggest voltage. While the smallest value of the resistor will drop the smallest voltage. That is how you can instantly identify which resistor that will drop the most voltage in a what? Series circuit. Okay, so therefore, the voltage that will drop across the resistor R1 from Ohm's law will be what? V1 equals to what? From this Ohm's law will be what? V1, which is equals to I multiplied by what? R1. And the voltage that will drop across to R2 will be V2, which is equal to what? I multiplied by what? RO2. And the voltage that will drop across to RO3 is V3, which is equal to what? I multiplied by what? RO3. So if all resistors share the same current, I mean if all resistors, if the same amount of current flows or passes through all the resistors, if they all share the same what? Current, then voltage drop is proportional to what? Resistance. I mean the voltage that will drop across the individual resistor is equal to what? Resistance. Since all the circuit elements which are the value of resistor share the same current, the voltage that will drop across the individual resistor is equal to what? The resistance of that one resistor. It depends on the what? The value of the what? Resistance. It depends on the values of the what? Resistor. That is what will determine the amount of voltage that will drops across that what? Resistor. Okay, let's solve this example. Let's solve this example. Let me clean the entire solving. Okay, let's solve this example. So in this circuit, we are given that the resistor R1 is 3 ohms, and R2 is 6 ohms, and R3 is what? 12 ohms. And the total supply current is what? 1 amp. And the total resistance is what? 21 ohms. From this circuit, all the parameters are given, and we are asked to what? Find what? Find what? The voltage drop across what? Each resistor. We are asked to find the voltage drop across each resistor. So from Ohm's law, the voltage that will drop across for R1 will be V1, which will be what? I multiplied by what? R1, which will be, since we are given the value of current, the value of current is 1 multiplied by what? The value of what resistor, which is 3, which will be what? 3 volts. So that it is 3 volts that will drop across the resistor what? R1. And the voltage that will drop across the resistor R2 will be V2, which will be I multiplied by what? R2, which will be 1, since the value of current is 1 multiplied by what? The value of resistor R2, which is 6 ohms, which the voltage that will drop will be what? 6 volts, because 1 times 6 is what? 6. So the voltage that will drop across the resistor R3 will be V3, which will be I multiplied by what? R3, which the current is 1 multiplied by what? The resistance value of what? R3, which is what? 12 ohms, which will be 1 multiplied by 12 is 12 volts. These are the what? Voltage drop across each of these resistors in this world circuit. My question is, what do you observe from this voltage drop? I observe that this 12 ohms resistor, which resistor R3, drops half of the what? Total voltage. The total voltage is 21. It drops what? 12 volts, which is half of the what? Total voltage. Which means the biggest resistor always gets the biggest share of the voltage. If you can notice here, you can see here, this resistor R3 is the biggest resistor here. That is why this resistor R3 took the what? The biggest, drops the what? Biggest voltage. Because what? The higher the what? The value of the resistor, the higher the voltage that will drop across the resistor, which means the biggest resistor is equal to what? Biggest voltage drop. While the smallest resistor, which is the 3 ohms, drop what? 3 volts, which means it is this 3 resistor R1 that drops the least voltage in the world circuit. What are the common mistakes students do make when solving problems like this? They assume that voltage is shared equally. They assume that in a steady circuit, voltage is what? Shared equally. Meanwhile, it is not so. That will only happen. Voltage will share, the resistor will share the same amount of voltage if the value of the resistor is what? Equal. If the value of the resistor is equal, that is the only reason why the voltage that we drop across the individual resistor will be what? The same. Okay, let us say from this circuit, let us say we have, let me just explain the statement I just made. Let us say we have 4 ohm resistor here, and we have 4 ohm resistor here. From this circuit, we have that all the resistance values are what? The same. So the voltage that we drop across the individual resistor will be what? The same, because what? The value of the resistor are the same. Okay, let us confirm whether the voltage that we drop across the individual resistor will be the same, since the resistance value of each of the resistor are the same. So from this, the voltage that we drop across resistor R1, which is V1, will be what? I multiplied by what? R1, which will be 2.4, which is the value of current which is given, multiplied by what? 4. And our answer will be, from my calculator, 2.4 multiplied by what? 4 will be what? 9.6 volts. And the voltage that we drop across to R2 will be what? V2, which will be I multiplied by what? R2, which will be 2.4 multiplied by what? 4. It will still give us what? 9.6 volts. And the voltage that we drop across to R2 will be V3, which is I multiplied by R1, which will be 2.4, because the circuit current is 2.4 multiplied by what? The value of the resistor R2, which is 4 ohms, which will give us what? 9.6. If you can notice here, the value of the voltage drop across the individual resistors are the same, because the resistance value of each of the resistors are the same. That is the only reason why the same amount of voltage will drop across what? Each of these resistors. But let me tell you guys one thing. The moment one of these resistors values increase, if one of these resistor values increases, that particular resistor that increase will start stealing most of the voltage. That is how the whole thing works. Once one of the value of the resistor is increased, that means say we increase the particular value of the resistor from 4 ohms to 6 ohms. We will notice that this particular value of the resistor will start stealing most of the voltage. Let us confirm. Okay, from this we know that, let us confirm what I just said here. We know that V2, it will be what? 2.4, which is the circuit current, multiplied by what? The value of this voltage, which is 6. So 2.4 multiplied by 6, it will give us what? 14.4. Are you seeing? Once this value of the resistor increase, that is the reason why the value of our voltage drop according to the resistor increases. So if this value of the resistor is being altered, this particular resistor will start stealing most of the circuit voltage. That is how the entire circuit operates. Let me give you guys this formula. The same value of resistor is equal to what? The same voltage drop. If the value of resistors are the same, the value of the voltage that will drop across the individual resistor will be the same. From this circuit, when we have 4 volts here, you notice that the value of the resistor are the same, which means the value of the voltage that drop across the individual resistor were what? The same. But let me give you another formula also. Different resistor values equals to what? Different voltage drop. If the value of the individual resistor are different, the voltage that will drop across the individual resistor will be different. That was the reason why, if you can observe from this circuit, the value of the individual resistor here are what? Different. We have 3 ohms, 6 ohms, and 12 ohms. That is the reason why the voltage that drop across this individual resistor were what? Different. They were what? Different. So if this video is helpful, do me a favor by dropping big arrow equals to big drop in the comment section. Drop it in the comment section that big arrow equals to what? Big drop. So I know you watch this video to the end. Drop in the comment section big arrow is equals to big drop, so that I will know if you watch this video to the end. And don't forget to like this video and subscribe for more videos. Subscribe so that whenever I upload video like this, you will be notified. And don't forget to share it to your friends and loved ones. See you in my next video. Bye.